This is the session on Can AI Read and Count? Assessing computers with an OECD test. Imagine that a computer system with AI took tests on numeracy and literacy. How well would the AI system perform on these tests? So a panel of experts in AI rated items in the numeracy and literacy assessments of the 2011 Piac Test. That's the Program for International Assessment of Adult Competencies. And Piac, of course, as probably all of us know, are administered to thousands of adults aged 16 to 65 in several dozen countries throughout the world. So, as moderator, let me introduce the participants on this panel. Stuart Elliott, an economist by training, led this project. He's a senior analyst at the OECD and a scholar at the National Academies of Sciences, Engineering, and Medicine in the United States. He is leading the AI and the Future of Skills project. He authored a very important 2017 report on computers and the future of skill demand, which is very relevant to today's discussion. Ken Forbes is a professor of computer science and education at Northwestern University. He has conducted research and developed AI systems in many areas, including reasoning, sketch understanding, natural language understanding, and intelligent educational software. He is an award-winning fellow and leader in the Association for the Advancement of Artificial Intelligence, as people call it, AAAI, and Cognitive Science Society, as well as many other societies. Chandra Bhagavatula is a senior research scientist at the Allen Institute for AI. He has investigated common sense reasoning, natural language generation, and the intersection of common sense and vision. He was a co-recipient of the AAAI Outstanding Paper Award in 2020. Myself, Art Graesser, will serve as moderator. I'm a professor in psychology and the Institute for Intelligent Systems at the University of Memphis. My research is in discourse processing, education, and cognitive science. I've developed a number of computer systems such as AutoTutor and Cometrics that analyze natural language on multiple levels of language and discourse. And oh yes, I served on a number of OECD expert panels on PISA and Piac, including this Piac 2011 test. So let me now turn it to Stuart Elliott. He'll give you a brief overview of Piac, the rating task, and some results. And again, he's the leader of this project.
Thanks, Art, for the introduction, and to all of the panelists who are participating today in this discussion, and to all of you for the help that you've provided in the project up to this point. So I just wanted to start, as Art said, talking a little bit about the Piac test and about the exercise that we carried out with it in relation to AI. As Art mentioned, Piac is a test of adult literacy and numeracy. And so its focus is to understand the sort of practical tasks that adults carry out using literacy and numeracy in their everyday lives. So you can think about it with respect to things like understanding the instructions on a bottle of medicine, or the process of comparing descriptions of two different cell phone plans and understanding which one might cost you more. So those are the sorts of everyday tasks that the Piac test wants to understand. And the point of the test is to figure out how well can adults in different countries carry out those tasks, and so that we can understand that level of skill and literacy and numeracy, how it relates to people's education and how it might relate to the jobs that they carry out. 5 years ago, we asked whether we could use the same test to give us some information that the policy community could understand about what AI can do. So the notion was, this is a test that people are familiar with, who talk about education, talk about jobs, and it provides a way of thinking a little bit about the different skills that people have. And so we wanted to know, could we use the same instrument to provide some information about AI? So we took the questions on Piac and we brought them to a group of AI researchers with the disarmingly simple question, can AI do these things? Now, I'm not an AI researcher, and so I can ask a simple question like that perhaps without being embarrassed and without knowing the trouble I'll get into. And this asking the question immediately resulted in a long conversation about what should the ground rules be for answering a question like that. When we talk about designing a system that could answer the Piac questions, what do we mean? So, for example, how do we give a question from the Piac test to an AI system? What does that mean? Are we talking about giving it the exact same thing that an adult gets, or are we allowed to change it in some way? As another example, if you talk about developing an AI system that can do these things, how long can you take to do that? Are you talking about something that you can give me next week or 10 years from now? Is that still fair? So we had to answer questions like that so that the group was all on the same page. And then everybody went through and did their ratings individually. Then we aggregated the ratings up and analyzed them similarly to the way that we analyze the results when adults take the test. And we can see which answers they get right and which answers they don't get right. So we did that 5 years ago. And then this past December, we did it again, the 5-year update. We used roughly the same ground rules as we had used 5 years ago. And we brought together a group of experts again, half of whom had participated five years ago and half of them who were new to this. And so we went through the same process. And now we're in a position to say a little bit about the comparison as a result of those two efforts. With respect to the literacy dimension in Piac, the exercise suggests a clear improvement with what it's suggesting on the side of AI capabilities. The AI researchers rated more questions as possible for AI in 2021 than they did 5 years earlier. There was also a smaller difference across the experts between the pessimists who didn't think that AI could do very much and the optimists who thought that AI could do a lot. So that difference narrowed over the 5 years, suggesting that there was a certain amount of convergence across the expert community and the understanding of the literacy capabilities for AI. And then with respect to the 5-point scale that we typically use to talk about Piac results, 5 years ago, the results suggested an overall pattern that was consistent with roughly a level 2 on the Piac scale. And this most recent effort at the end of last year suggested that the results are now closer to level 3. Now, if you don't know the Piac scale, a difference between a level 2 and a level 3, it's not quite clear whether or not that's a big deal. As it turns out, with respect to the adult population, that is a big deal. So thinking about the level 2 back in 2016, there is almost half of adults who are in levels 3, 4, or 5 on Piac, so a total of 46%, who have literacy capabilities measured by Piac that are clearly better than the level 2 suggested on the AI side 5 years ago. But for the level 3 comparison with resulting from the exercise in December, only 11% of adults are at levels 4 or 5 in Piac. So only 11% have literacy levels that are clearly higher than the level 3 results suggested from the exercise this past December. So that suggests that there's a meaningful change in the capabilities on the literacy side in comparison to what people can do. On the numeracy side, the results don't look anything like that at all. So the AI researchers actually rated fewer questions as possible for AI in 2021 than they did in 2016. A little bit of a puzzle and raising questions about sort of interpreting what the process is and how to think about the question of what it is that an AI can do. The difference also increased across the expert range from the pessimists to the optimists. And finally, the pattern of performance 5 years ago looked roughly like a level 2 in numeracy, although it wasn't a very good match. And again, the best match is probably still level 2, but not very clear. So we're in the process now of trying to further understand these results and the extent to which a process like this can help the policy community understand the kinds of capabilities that AI has. And so I'll stop there and turn this back to Art and the panel to talk more about these ratings and what they mean.
So at this phase, I want to hear a little bit from Ken and Chandra on what may have changed in the world of AI in the last 5 years between, sorry about that. Okay. What may have changed in the last 5 years in the world of AI that potentially may explain the difference? Has there been major changes that may explain the changes in the ratings? And has AI evolved in some fundamental ways? So I'd like to hear from both Ken and Chandra what their thoughts are on that. Who wants to start? Ken, you have your mic on, so why don't you start?
Sure. So there's 3 things that are really driving advances across AI. One of them is more data. One of them is more compute power. And one of them is a lot of people working to make scientific progress. And so there's actually 3 revolutions going on right now in AI. One is deep learning. Everyone's heard about that. But there's also knowledge graphs, and there's also reasoning. And those 3, and by revolution, I mean significant economic benefit and technologies in daily use, not stunts, not laboratory experiments. And so you're now, the things that you can now get off the shelf are staggering compared to what the research community could do 5 years ago. And so more and more things are getting regularized and engineered and rolled out. And so that's a sea change.
Mm-hmm. Okay, Chandra, what are your thoughts on that?
Yeah, so I totally agree with Ken. Adding on to that, I think specifically talking about literacy, there has been a boom in language understanding technologies recently, starting from pre-trained language models like Elmo, BERT, and GPT-3. You all might have heard about all of these. And these are really revolutionizing the language capabilities that are out there right now. And we are at, I think we are at a stage where given a narrow domain or a narrow problem, we are able to solve it using AI as long as we can get some label data for it. Of course, the key challenge is being able to generalize out of it, but for a narrow problem domain or a narrow set of problems, we are able to solve them reliably well. So I think that's where we are at, and yeah, looking forward to what the following years hold.
Well, let me press this a little further. I know one of the issues brought up on the panel was some tasks in AI are very specific, like it may be visual pattern recognition, or it may be natural language, or it might be interpreting a table with numbers according to a template. But some tasks is a combination of these. Has there been advances in AI that kind of integrate components?
Not to the degree there needs to be yet, and that's a really good point. So think about household robots. You have Roomba. You don't have Rosie from the Jetsons cartoon. You don't have something that you pick and place and carry things safely in your house. Why? Because the robustness you need in terms of sensors, the robustness you need in terms of flexible world knowledge and intelligence just aren't there. So for AI systems, there's framing the problem, and then there's solving the problem. And that's true for humans too. And we've made a lot more progress at, given a specific problem where someone set it up for you, like question answering in the context of web search, we have algorithms that are really good. Having an integrated intelligence that has multiple capabilities and understanding the trade-offs in those capabilities and flexibly wielding those in novel circumstances and adapting to those humans around it using their modalities rather than having it to be reprogrammed, those are things where we're not so far advanced.
I see. So, Chandra, do you want to respond to that?
Sure, yeah. So I agree again. So there has been some work, of course, not as much as you would like, in understanding tables and text or graphs and text. Like there are some combinations of these, like multimodality is another line of research that is growing, but I don't think we are at a stage where we can deploy them in real world situations. And just thinking about the literacy problems that we were getting here, one of the points of discussion during our workshop last month was whether this input is given as is or whether it is parsed already. And that itself adds a significant effort that people need to do. Like, for example, at the Allen Institute for AI, we have this Semantic Scholar project, which is trying to parse PDFs of scientific documents. To be honest, this seems like a narrow domain enough, but that parsing alone, people have spent several years just doing it reliably well, and there have been like multiple iterations within our team to just do it well enough. So that itself is a pretty hard problem. So multimodality and being able to do real world problems at reliably good levels of performance is still a challenge. So narrow works, combination of narrow things doesn't work yet, generalization doesn't work yet. So there are a mix of things going on.
Well, let me add just another follow-up question. Both of you have done research on reasoning, done major research on reasoning. Can reasoning, of course, you can reason about a domain like spatiality or something, but can you use reasoning to try to help integrate these different components? To what extent can reasoning help solve that problem, integrating the different capabilities?
Oh, it's going to be absolutely essential. So, for instance, when you're reading a problem, or reading at any point, you've done a lot of work on this, Art. So yeah. But you're building up a model of the situation, right? And you're bringing in world knowledge to help figure out what's going on. Even the sample problems that we're going to show them in this panel have examples of that. We're even to interpret the question properly using world knowledge beyond what's inside the question itself. And so you have to look over your understanding with what you've done on something and say, is this accurate? Is this correct? So one of the things people are doing is we're monitoring and reflecting on our own operations. And that's something that today's AI systems don't really do much of. There are some exceptions. One of the reasons that IBM's Watson works so well is it had little things for every capability that were estimating how accurate it was on that specific inputs and outputs. And wielding those together to have a model of how accurate its answers were essential to its performance. And most AI systems don't do that yet. And they need to, and especially as they get broader and try to adapt over weeks and months and years and working with people, those sorts of capabilities are going to become essential.
Yeah, and just as a reminder, humans have trouble with that too. You know, and so it's not like we're perfect creatures or intelligent systems.
Yes, but when students say to you, I have the concepts, but I can't solve the problem. It's like, oh, yeah.
So, Chandra, do you want to say anything else before we turn to the next phase of this?
Sure, yeah. So I think, reasoning is very crucial, especially to generalization. One challenge that I see, though, is what do we define as reasoning? Like right now, in AI systems, when we are building them, we coax the problem into just right that kind of format, that kind of input format, that kind of reasoning problem that AI systems can really do right now. But again, generalization seems to be a problem. Yeah.
Okay, let's turn to now some concrete examples. And so what we're going to do here is show some particular problems from Piac, and then Ken and Chandra will give their ratings and justifications. But also we want you to vote. So we want you to vote, the listeners here. Do you think that AI technology is capable of solving this task? Yes, no, or maybe. So here's the first problem. This is one that from literacy. It's a literacy item on preschool rules, and it's got all natural language here. There's no visual thing or charts or anything. So the question is, what is the latest time that children should arrive at preschool? Okay, straightforward question. And you have to read all these rules. And by the way, this is a level 3 item in Piac, which means, as Stuart mentioned earlier, about 46% of the adults throughout the world can answer this correctly. 54% can't. And so you have the main question and all these constraints, and sometimes, notice there's two times here, the 9 a.m. and the 7:30 a.m., so there may be some competition in two different times, and they have to reason through which would be the later time and interpret that, and there's a lot of other distracting information. So at this point, I think people should vote. Once again, the options are yes, maybe, and no. Okay? And fortunately, we have Abel and Nora that will collect the votes. And so, meanwhile, Ken and Chandra, what are your thoughts? Do you think this is a problem that an AI system could solve?
Are we allowed to say now or wait for the votes in?
Just go ahead and talk.
I think yes, definitely. Like I actually tried it on a system that's available online. Yeah, I entered this text, this question. It was pretty easy to get the answer.
Very good. My gosh. What about you, Ken?
Oh, same thing. I would add that there's a subtlety here, which is so when people are reading it, they're building a scenario and they say, well, there's an arrival time and have your child here by 9 a.m. Mm-hmm. That's relevant to arrival, right? Because they have X here by Y. It's a pretty common construction. Mm-hmm. Now, there is this little subtlety that nags, right? Breakfast will be served until 7:30 a.m. If the child is going to be eating breakfast, it in fact needs to arrive before 7:30, right? So that's the case where, but then Graesser and Maxim say, look, you weren't told the kid needs to have breakfast, so let's assume that they don't. And so 9 a.m. really is the right time here. So yeah, it's easy, but you talk to a human about this question afterwards, they may well raise the breakfast point. I don't think our AI systems would raise that point.
Well, interestingly, I think it was 56% of the panelists agree with you that it could be solved by AI. So this seems to be an example where there's a lot of agreement. About half of the remaining 44% said maybe, and the other half no. So that's what the vote was, and it looks like there's agreement here. So why don't we go on to the next question, which this is one on wind power station. It's a numeracy question, and it's level 4 in Piac, which means that only 11% of adults can answer this correctly, adults who take the test throughout the world. And so it's more difficult. And notice the question is, how many wind power stations would be needed to replace the power generated by the nuclear reactor? And so the nuclear reactor, it says in the top paragraph, has 3,572 gigawatts per hour, or per year actually. And so then you have other information about the wind energy, and that's now on a different scale with megawatt hours. And interestingly, the picture is totally irrelevant. That's just there for color or context. You don't have to interpret it, but you do have to interpret that chart at the bottom. And you have to worry about the scaling, namely for how many megas are in a giga, namely 1,000. So you have to scale things properly, and then you have to do the mathematics. So that's this problem, and it's a harder problem. So I'm curious on what both Chandra, do you want to start this time, or
Sure.
And then Ken, yeah.
Yeah, I think, this is a problem of putting together information from different parts and like organizing it correctly. And that is definitely a challenge. In my opinion, I don't think there is a system out there that is able to reliably do these well. For example, this understanding, like it needs to first understand that the amount of power generated by this nuclear reactor is 3,572 gigawatt hours, and that there is a mismatch in the units, and that there needs to be a conversion done, and then you need to divide 3,572 by into 1,000 divided by 6,000. So that's coming up with that mathematical formulation is hard. Of course, once we have that, it's pretty easy to solve it. So that parsing is pretty hard right now, in my opinion.
Yeah. So think of this in terms of, is a classic distinction in qualitative reasoning research: model formulation versus model reasoning. So model formulation here is the hard part. In terms of once you have the model, oh my God, it's easy, because, well, for instance, the back of the envelope reasoner my group has, including the units, conversions, would handle this trivially, right? This is like an easy 3-step inference. And, with about a year's work, you could improve even the natural language system we're using to extract that sort of information more reliably if you put a reasonable sized team on it. So this is the sort of thing where if you try to do it right now, no. If you wanted to do it in a year, like a broad variety of problems like this in a year, I think it's actually very feasible, because we already understand the stuff to do with the model once we have it. That's pretty easy.
Let me just press.
One more thing to point out here. This is another case where the real world intrudes. So when you do the math in this problem, there's a decimal, right?
I know.
It's not even. Now, you would normally round down because it's less than 0.5. But in the case of sizing problems like this, a good engineer knows you round up, because it's better to have a little extra capacity than not enough capacity. And that's something that, again, is a concern that you have to understand more about the world to really know which way to do it.
Yes. In fact, I wondered about it, whether they allowed 2 answers to this, or whether you'd have to round up what was correct. And I don't know what the answer to that is, but that, so let me ask you, if you wanted to have a business that could actually handle problems like these, not just this one problem, but a class of problems very similar, what sort of corpus would you need? And
Well, ironically, so the people who are looking at back of the envelope reasoning, so my group has done work in this area. Alan Bundy's group at Edinburgh has done work in this area. AI2 actually just started a new data set on this sort of problems, right? So so there is interest, and in fact, in part because these are interesting, cool problems, but model formulation is critical. So for example, how much oxygen is left when the Mir space station had a leak, right? So how much oxygen do they have? Well, a detailed model of that isn't going to be possible, but you could look at the geometry of it and come up with rough models pretty quickly. So one of the interesting things about this is how do you actually say, yeah, a detailed model. I don't have engineering drawings, but how do I get a back of the envelope characterization that tells me what my options are? What things do I have to worry about? That's again the sort of thing where even in model formulation for the bigger real world problems, you need to be able to do things like this. So that's one of the reasons why it's such a juicy problem.
Chandra, did you want to add to that?
Yeah, quickly, I believe these kind of problems are called fermi problems, and yeah, we do have a new data set come out with showing a lot of interest in these kind of problems. I do think it is feasible given some reasonable amount of effort. Yeah, there are some challenges right now, especially in the formulation of parsing out the right information from this text and organizing it in a way such that solvers can solve it. So I think it is doable, but yeah, there is some reasonable effort that needs to be put into it.
You know, what's interesting is the votes were 80% yes, it could solve it, and 0 say no, with 20% maybe. And so this is an interesting maybe difference between accomplished experts in AI making judgments and other people who vary in many ways. Some, you know, a distribution of interested researchers and economists, and public policy people on how they would judge it. Okay.
Yeah. Sorry, quick thing. It does seem a little counterintuitive that computers are not good at math, but it's not actually the math problem here that is really challenging. Like once you have the formulation, doing the math is pretty easy.
It's trivial.
It's all the thing. I mean, we are so transparent at language understanding that the subtleties are very difficult to grasp. That's one of the reasons why, for instance, the ELISA effect is so dangerous, right? So you see things like transformer models being used to write editorials, run away, hold on to your wallet, right? Because the problem is we as language users see language being used and think the other thing is like us. In many circumstances, it's not. And so that's a problem we all face.
So let's try the next problem. This is a literacy problem on physical exercise equipment. It's only level 2. The question is, which muscles will benefit most if you use the gym bench? And it's level 2, which means 80% of the adults throughout the world can answer this. And this is really kind of a lookup table. You have to interpret the different labels in these charts, and then you see that you know, the one under gym bench, there's a very good option, and that's got to be the best one if you want to, you know, exercise your muscles. So this is kind of a lookup table, and it's a pretty conventional table, although there are maybe some small aberrations with these visualizations. But so what do you think about this one? How would you vote on whether AI could handle this? Ken, do you want to start this time? Or Chandra, you're on already, so you start, Chandra.
Sure, yeah. I think this is doable. I think the only problem here is parsing this table into a conducive format. Beyond that, I think there are systems out there that can do this kind of reasoning. I actually did some work in table understanding, several years ago, and of course that line of research has grown a lot. I moved away from it, but I see a lot of table-based question answering systems that should be able to solve this pretty easily, as long as we formulate it or parse the input in a conducive format.
All righty,
Yeah,
Ken?
I agree. So, if you look at any of the cloud-based cognitive services, they're now including some kind of table understanding. Now, do they handle tables that have gaps with glyphs in the middle of them? That I don't know. Okay, but that's not rocket science. And the simple little qualitative representation for the ordered values, like very good, good, average, that's duck soup easy. Any language system worth its salt will be able to say very good is better than good, and good is better than average. And so I think that's actually quite easy, assuming the table thing works.
Interestingly, the votes are 53 or 54% said yes. About 36% said no, with very few maybes. So, this is an interesting one, kind of intermediate. And questions like these, raise issues on this methodology. So one other thing I know we discussed is how conventional the table formatting is, the templates for tables. If you get one that's not in the arsenal of alternative table templates, there could be challenges. Okay, why don't we go on to the last example problem? And this is another numeracy one, level 3. 43% of the adults can answer this one. And the question is, during which periods was there a decline in the number of births? Click all that apply. So there's more than one alternatives. And so as you can see, you have this picture that can be kind of distract from the table, and you have to sift out the relevant information of the numbers and interpret the graphs. So so what do you think about this? I know, Chandra, you've looked at reasoning and visualizations. Why don't we start with you?
Sure. I was actually not too sure about it. I don't think systems are out there that can solve this problem with some caveats. So if the question was just slightly different, or the answer options were slightly different, like if we looked at the period 1957 to 1977, instead of 10-year gaps where the points are consecutive and those numbers are like clearly decreasing, I'm not sure. I'm also not sure if a system can reliably extract these aligned like year and population sizes. So if those are done, maybe the language part of it might be doable. I'm actually not sure. I think I would rate this 50-50 for from where I stand.
Okay, what about you, Ken?
Yeah, I agree. So in fact, the first time I looked at this problem, I was on a crufty screen, and I had trouble pulling out the lines and the numbers. Okay, because but look, once you see that there's straight lines and then dots, so now you say, well, how do I interpret this dot? Well, there's two annotations, right? So in sketch understanding, there's this idea of annotations. So I have two annotations, and the things on top and the things on bottom are probably different axes, right? So now you're starting to do abductive reasoning. And from the abductive reasoning, now you're framing this thing as a kind of graph problem because someone's told you about periods and it says, look at the graph. So they're telling you, this is how to interpret it, right? You're getting strong top-down signal from language, which then you use to help guide your visual processing. So for people, one of the reasons this is easy is exactly that kind of multimodal understanding. So this is the sort of thing where the number of conventions is small. I don't know that anyone's really gone out and said, let's formalize them and stick them into our vision systems. Okay, but it does look like the sort of problem that could fall pretty nicely before too long.
And I see from the voters that 53% said it could solve it. And then at the other extreme, 35 or 36% said no, and with few maybes. Whereas Chandra, you started out more at the borderline. you know, it's kind of interesting. Once again, experts in AI may have a different viewpoint than people who are, you know, people who are not, you know, people who are building systems necessarily.
Yeah.
Okay.
Sorry,
Yeah.
one quick
Yeah.
point I wanted to add. So I think adding on to what Ken said, we bring our background knowledge to decipher that 1957, 67, and so on are years, and the numbers below them are population. Those are not labeled in the graph. So that kind of extraction is what I think is currently hard to do. Like, we need some background knowledge and visual understanding. There are, of course, some systems that try to approach this problem, but I don't know if they are readily available to solve this problem. Given enough effort, we should be able to do them.
So one of the problems with today's AI research is data sets are often set up to where you're doing very simple local things. And so people focus on point solutions as opposed to broader reasoning capabilities. They're trying to get higher precision understanding more broadly. So the graph problem is much easier if you see it's a graph and you see that the answers are talking about years, right? That's a very strong context, and humans are very good at using those top-down priors to help guide their reasoning, and our AI systems need to do that more.
Yeah, and this does point out possible future, you know, tasks and challenges in AI. A study like this can motivate certain directions in AI in the future. So let me turn now to the next phase, where I want to ask the panel, and I can have my own opinion on this question too, as being one of the raters. What do you think about this rating task and how it, I mean, if you were to compare real AI systems that actually try to solve this versus a rating task by experts, what do you think about this methodology, this approach? Do you want to start with you, Ken, or Chandra?
I would say it gets us part of the way there, but not all the way there. So you have to understand these basic capabilities, what's hard and easy. It's harder for this to measure the model formulation aspect, because that's now talking about natural understanding of multiple modalities and having lots of world knowledge. And then, of course, there's also the bigger implication for policy. So if you're talking about policy, there's also, for instance, tasking a system, right? So a system that's going to be in the workplace has to have enough social skills to where you can tell it what to do, tell it how to do it in the same amount of data that you give a human collaborator, not millions of examples. And if you really want it to be in the workplace effectively, it has to be good enough to be a collaborator. And so those social skills are not something that's measured. So this will get us some of the way towards measuring impact, but it won't get us all the way. And part of what's happening is we're making our information office work more like factories, right? So in factories, you have robots doing pick and place and doing all sorts of crazy things we don't have them doing in the home because they engineer the environment. And with cloud-based information systems, we're getting more engineering of the intellectual environment so that the information environment is now susceptible to automation far more than it was when everything was oriented around paper. So that's one of the sea changes we're seeing right now, I think.
Chandra, what are your thoughts?
Yeah, I think, the test and the assessment is pretty useful in getting some kinds of information for sure, like the insights that Stuart shared earlier in this session. They were, enlightening or informative. So the disconnect though between what AI researchers think about AI systems and this is that when I think about it, I'm looking at a data set as a whole and not as individual instances. So if we were to attack individual instances, I want to go back and say, yes, we can, with some effort, solve individual instances and build customized solutions for each of them. And then depending on which one you encounter in real life, you can just route them over to one of these subsystems. But doing that in a generalizable way, like as Ken was saying, if we want like systems or machines to be collaborating with us, then there are significant challenges. Being able to understand the social interaction, being able to generalize to situations that you have not seen before, that is super critical. So that is still lacking. So we should try to go there. And there is a lot of talk about like machines replacing humans. I don't think that is going to happen anytime soon. And the way I see it is like machines and AI collaborate with each other, much like chess. Like in chess, several years ago, machines were better than humans. That does not mean humans stop playing chess. They still play chess. They are just enhanced by the competency of machines. They just got better at chess with the invention of all these like super powerful engines. So I think looking forward to more collaboration.
I guess I'm a little less sanguine. I agree with Chandra on the critical nature of having human AI collaborative systems in the future. That's the only way it's going to work. It's the only way you're going to build trust. It has to happen. But there is things like, for instance, Microsoft just basically said in the Wall Street Journal interview that their financial hiring was flat from 2008, even though the company exploded in size because they used automation. So those are jobs that didn't happen. So they kept their headcount not changing by adding more AI to the system. And if you look at places in the pandemic that are saying, well, one response to people wanting reasonable wages and staff shortages is we're going to automate more. And so we are seeing automation happening. It's not full scale, it's limited, but as AI gets better, it's going to grow. And we have to think pretty carefully about what we want that to look like.
Well, just one comment, a couple of comments I'll add to this is I like this activity of getting expert judgments. I really think it helps us understand the potential of automation and its limitations. I also like experts doing it. But I would like, and there is a question that was raised very relevant of it, I'd like to see actually comparisons between the experts and actual systems that try to do the task. And so, and both can learn from each other. So there was a question from Peter Sihan, have researchers given questions to LLM, or it's a type of GPT-3 model, to measure performance directly on the Piac items as a supplement to your expert elicitation method? And so that once again points to wanting to compare actually working systems trying to solve these versus the judgments of experts.
I have to stop myself from going off and building something after some of these meetings, right? Because it's some of these problems are just so tempting. But.
Yeah. So and we are going more to the question period, but one other comment I wanted to make is when we made these judgments, not all of us were experts in all components. Like it's, of course, you two are Renaissance AI people, right? You try to solve everything, right? But some people are good at visual pattern recognition, others on templates with tables, others on natural language processing. And it's hard to find, in my view, experts that know how to integrate the different modalities and map one component onto another component in order to come up with an answer to a very specific problem. And so how do you, let me just ask you two, if you were to do the rating task any differently to provide more informative information, how would you do it?
Well, one way to do it is to have a team of people chartered to go off and try to say, well, you think you can do it in a year? Let's see, right? Let's make that bet and let's try to cash it out. So it's very expensive because people are scarce. But empirically, that's really what's going to tell the tale in some ways. In terms of specific skills, I do think the cognitive architecture issues are much broader, and finding a way to do that isn't nearly impossible to evaluate, right? Because these things have the advantage that they're fixed and closed and finite and short, as opposed to, can a system play well with others over a year in doing a real job? That's incredibly harder to measure, right?
Interesting, yeah. One question that we had, and there's some questions coming up, some more complicated than the others, but one question, are there any known AI capability assessments on other educational tests that have been made? And I understand that there has. I remember reading a special issue of a journal, one of the AI journals, where they had a set of articles of trying to take a test, but it's been a while since I've read that special issue. Are any of you aware of any tests that were taken by AI systems?
Oh, sure, but generally you have to take like more than a few grains of salt on this. So Bennett mechanical comprehension tests, there's been systems that do subsets of it, not the whole test. The whole test is really hard and it requires visual understanding. There was someone who claimed that ConceptNet was equivalent to a 5-year-old, but the problem with that was the test required subjective evaluation, and the person doing the evaluation was part of the research team, so it wasn't really objective, and so I have no idea how to interpret that finding. And even when the findings are solved, so my own group, one of our systems is basically in the 70th percentile at Raven's progressive matrices, which is the best known test for human fluid intelligence. That does not mean it's better than most adult Americans at fluid intelligence, okay? So even though it is an accurate cognitive model to the extent that we can measure that, still it's working in such a different way that fluidity in re-representation is in a visual way that's not reflected across the system's entire things the way it would be in a human. So in general, that's a problem with human norm tests. You have to look really hard at exactly how the system is doing it. And in no case today is there one system that you sit down and you give it the same modalities you give to a human and you give it a whole battery of things. That's not there. Nobody has done that. And until that happens, you have to be super, super cautious in evaluating these results. I still think human norm tests are great, because one problem with machine learning today is they'll take a term like reading comprehension, and they'll get Turkers on the data set. And then when the machine does as well as the Turkers, they say human level reading comprehension, even though they didn't do the norming of the problems that any good psychometrician would have done before calling it a reading comprehension test. So the human norm tests at least have been carefully vetted by someone, as opposed to many machine learning data sets, which you have to take, again, with extra grains of salt.
Chandra, did you want to say something? There's a couple of other questions I might want to ask, but yeah, Chandra.
Sure, yeah, so very briefly, I wanted to mention two things. So both of these came out of AI2. So I think in 2015 or so, there was a system that was able to solve SAT geometry problems at the 8th grade level. And I believe in 2019, they were able to solve like 8th grade science test questions as well. In both cases, for a while, it was tried that you only give the system the reading material that children get, and that is pretty hard to do. The breakthrough comes when you start using like tons and tons of more data that models have access to nowadays. So again, yeah, echoing what Ken was saying, that there are big grains of salt. Like, sure, we got this system that is able to solve these 8th grade or some SAT problems. Have we tried like slightly modifying them, like generalization out of that into very similar problems that look like it, but at the same level, they're slightly different? Those kind of problems are not evaluated. So it's left to be seen.
We have a couple of other questions. I'm sorry we can't get to all of them, but one question did say, did we ever evaluate things like problem solving? And in the 2016 assessment, we did do problem solving in technology-rich environments. And actually, this may be a question for Stuart. Why didn't we do that again in 2021?
Yeah, well, there's a little bit of a problem with that domain, and my memory is we ran out of time in 2016, and I think sort of only 3 or 4 of you actually did that domain, but the reaction was to sort of max it out and say that the AI would be able to do pretty much everything. Sort of it's navigating inside a digital system and being able to make sort of typical software like Word and Excel, so do the kinds of things that you need to do in an office environment. So we didn't end up repeating it this past time because so just not quite sure how much we would learn from it. And I believe, and Art, you probably know more about the plans for problem solving in the next set of Piac. There's some concern about sort of having a richer conceptualization of the problem solving that's addressed on the test. And so next time around, that may be a more fruitful domain for us to use for this kind of exercise.
Well, I am on the expert panel for that for 2021, which actually the test is 2022 because of COVID, but it's on adaptive problem solving where problems can dynamically change in the middle. And there's more a metacognitive component in addition to cognitive. And I noticed some of the questions here addressed whether it knows about its reasoning, and metacognition is relevant to that. And so perhaps that can be taken up in the future, you know. I know we're about out of time, and we can't answer all the questions, but I did want to point out a session tomorrow morning, the very first session. It's a high-level session on the future of AI, stakeholder perspectives. And I don't know, Stuart, do you want to say anything more about that session? I know you recommended it.
I don't have a great deal addition to say. That's just an opportunity to hear what several high-level folks who are part of the OECD policy orbit, what their reflections are with respect to AI and its significance for a number of larger policy issues. And so we just sort of an interesting opportunity to hear some different perspectives about how the policy community is thinking about AI and its implications.
Well, we have 2 minutes left. For the rest of the panelists, do you have any last minute thoughts? Chandra, we'll start with you.
Sure. I don't have last minute thoughts, but I can answer one of the questions. I see this question about how reasonable is the concerning concept of paperclip maximizer posited by Nick Bostrom. I think not very reasonable given the current capabilities of AI. That book is a futurist view of what could go wrong, and it's an entertaining read, but yeah, given where current state of AI is, it seems pretty far off in the future, or maybe not at all.
Yeah, I think it's like worrying about traffic jams on Mars, to use a metaphor here. But so the thing to be worried about is how do we make AI enhance human life as opposed to putting people out of work and making most of us surplus? I mean, that's really the crux of the policy issue. And how do we arrange things so that we get the kind of world we want, to where AI systems are partners with us, collaborating with us, helping us work better, as well as taking on jobs that we don't particularly want to do.
Okay, Stuart, you have the final word.
Well, I have found this a delightful conversation. It's been great working with all three of you, and I look forward to having more of these conversations in the future. And I hope for our audience, this has provided some insight into how difficult it can be to answer what one might think would be very simple questions about what AI can do.
Thank you, everybody.
Thank you.
The session is now concluded.